What is vector search? Well, suppose that I have this thing. Could be text, could be an image, audio, any sort of data. And I want to find other things that are similar to my thing. How might I go about doing this? Well, first I want to start by making my things comparable. Imagine that I have data in my database and in my query. I can embed my data in vector space using a vector embedding model, like OpenAI's text embedding 3 large. Next, I can embed my query using the same vector embedding model. And now my query and my data are in the same vector space, and they're comparable to each other. Next, we can measure similarity, which is how we compare our vectors together. One popular method is the cosine similarity, which measures the angle between the vectors. Another popular method is using the Euclidean distance, or L2 distance, which takes into account both the angle between the vectors and the size, or magnitude of the vectors. Now, when I'm comparing my query vector with the vectors in my database, I can do this exactly, which means that I'm comparing the query vector against every vector in the database. This is precise, but it's slow as it scales linearly as I add more vectors to my database. A better alternative is to use an approximate nearest neighbor method, where you're comparing the query vector against only some of the vectors in the database by leveraging a vector index, an efficient data structure for vector search. In Azure Cosmos DB, we use the Microsoft Disk-ANN vector index. This allows us to compress vectors that are kept in memory and store an uncompressed graph data structure on high-speed SSDs. With efficient algorithms, this makes vector search, even at enormous scale of 1 billion plus vectors, fast and cost-effective. When combined with our NoSQL query language, it's incredibly easy to run vector searches at scale in Cosmos DB, even with query filters. Check out our Cosmos DB samples gallery to learn more and to get started with some great code samples for running vector search in Azure Cosmos DB.